Dear students, good evening and a warm welcome to CSAT Made Easy 2025 series, where we discuss the most exam specific questions and concepts from the angle of your CSAT paper of 25 year. I am Sachin Gopanal and our today's topic of discussion will be combination. I think 3 classes before we discussed permutation, and today we will be discussing another aspect of the same concept, combination. And in combination we will be concentrating on one particular concept. What is the concept? What is combination? And how do we find out combination of some things? What is the formula? Let's see that with the first question. And as always, we will begin with basic level questions, learn basic concepts and gradually rise up to exam level questions. So this is the first question. Let's read the question. Let's solve it and then understand how to solve the problems on combination. A, B, C and D are 4 points on a square. Each point is on a different side. How many triangle or triangles can be formed using any 3 of these 4 points as vertices? Okay, what is the question telling us? The question says that there is a square and on each side of that square, on every one side, there is one point. And they have named the points A, B, C and D. And they want us to find out how many triangles can be formed using these points, using any 3 of the 4 points. So how do we solve it? Let's draw a square and understand what the question is actually asking us. This would be a square. Okay. Let this be A, this be B, and this C and this be D. And they want to form triangles using any of the 3 sides. They can form ABC or they can form ABD or they can form BDC. Such way, how many triangles are possible? This question, it demands the usage of combination concept. Okay, what is combination? Combination is selection of some items. In how many ways can you select the items? That is the concept of combination. More specifically, first I will give you the formula of combination, then it would be easier for you to grasp the concept. What is the formula for combination? Combination goes by this formula. NCR is equal to n factorial divided by n minus r factorial into r factorial. Okay, what does this formula imply? It is like this. Let's understand the concept of factorial first. For example, 5 factorial would be 5 into 4 into 3 into 2 into 1. Similarly, 4 factorial would be 4 into 3 into 2 into 1. That way, n factorial would be n into n minus 1 into n minus 2 into n minus 3 into, that way up to 1. This is the concept of factorial. Okay. But what is this NCR? NCR, this denotes that there are a total of n number of items, out of which you need to select r number of items. And in how many ways can you do that? You can do that in n factorial divided by n minus r factorial into r factorial ways. Here n is the total number of items and r would be the number of items to be selected. Number of items to be selected. So in simpler words, combination is always selection. Okay. Let's apply this formula in this concept. How? Our formula is simple, NCR. Okay. In this problem, how many items are there totally? We have 4 points, right? A, B, C and D. So we have total number of items is 4 because we have 4 points. And how many do we need to select? we need to select only 3 of them because a triangle can be formed using any 3 of the points. So the total number of items is 4. The items to be selected is only 3. So what will our formula become? Our formula NCR, that will become 4C3. So what is NCR? NCR would be n factorial divided by n minus r factorial into r factorial. So this would become 4 factorial divided by 4 minus 3 factorial into 3 factorial. Okay. Now what is the value of 4 factorial? That would be 4 into 3 into 2 into 1, and this would be 1 factorial into 3 factorial would be 3 into 2 into 1. So we can cancel out 3 into 2 into 1, 3 into 2 into 1. Yes. Then 1 factorial, its value is 1, so it doesn't have any value. So ultimately, what will be the value of 4C3? That would be 4. So using 4 points, how many triangles can you form using any choosing any 3 of them? That would be 4. Okay. This was a very easy question. You could have counted it manually actually. However, to understand the concept of combination, to understand the formula of combination, we had to solve this. Okay, let's go to the next question. That would also be a very basic question. A, B and C are 3 points on the circumference of a circle. How many triangles can be formed using these 3 points as vertices? Okay, in the previous problem, they had talked about a square. Now they are talking about a circle. And in this circle, how many points are there that we need to take account of? There are 3 points, A, B and C. And we are to form triangle, right? To form a triangle, how many points do we need? We need 3 points as vertices. And how many points do we have here? We have exactly 3 points. So our formula NCR, here n is also 3 and r is also 3. So that would become 3C3. Yes. So let's just apply the formula. N factorial divided by n minus r factorial into r factorial. That would be 3 factorial divided by 3 minus 3 factorial into 3 factorial. That would give you 3 factorial divided by 0 factorial into 3 factorial. 3 factorial and 3 factorial, they get cancelled. So we are left with 1 divided by 0 factorial. So is it 1 by 0? Is it infinity? No. Remember one thing, 0 factorial, it is equal to 1. 0 factorial is not 0. 0 factorial, it is 1. So here that would be 1 by 1. So ultimately the answer would be 1. So using 3 points on a circle, how many triangles can you form? You can form only 1 triangle. So the answer is 1. Okay. So we understood the concept of combination and we also understood the formula of combination using these 2 problems. Let's go to an exam level question now. Let's read this one. 8 points lie on the circumference of a circle. How many quadrilaterals can be formed by connecting these points compared to the number of triangles? Let's understand the question once. The question tells us that there is a circle and there are 8 points on the circle. And those 8 points, you can form, using those 8 points, you can form quadrilaterals and you can also form triangles. They want us to know how many more quadrilaterals can be formed than the triangles. That is, find the number of quadrilaterals that can be formed and subtract it by the number of triangles that can be formed. So that will give you the difference between them, and that is what the question is asking us. So here we have a circle and how many points do we have here? We have 8 points. Okay. So let's find out first how many quadrilaterals can be formed, then let's find out how many triangles can be formed, and we shall subtract one from the other, and the difference will be our answer. For quadrilaterals, n is 8 because the total number of items is 8. How many points do we need as vertices for quadrilateral? A quadrilateral, it has 4 sides and 4 vertices. So we need 4 points out of these 8 ones. So the value of r would be 4. So NCR, that would become 8C4. What would be 8C4? Using the formula n factorial divided by n minus r factorial into r factorial. That would be 8 factorial minus 8 minus 4 factorial into 4 factorial. That would be 8 factorial divided by 4 factorial, 4 factorial. Further, how much would that be? That would be 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 4 factorial. We can cancel out 4 factorial and 4 factorial. Now we are left with 8 into 7 into 6 into 5 divided by 4 into 3 into 2 into 1. 3 into 2, that would be 6. So we can cancel 6. Then 4 will divide 8. 4 2s are 8. So you have 2 into 7 into 5. 2 into 7 is 14 and 14 into 5, that would be 70. So how many quadrilaterals can you form using these 8 points? You can form 70 quadrilaterals. Okay. Now let's talk about triangles. We are done with quadrilaterals now. Now we shall talk about triangles. Now for finding out the number of triangles, n is again 8 because the total number of items, that is 8 again. Our r would be only 3 because a triangle needs only 3 vertices. Okay. So NCR, that would become 8C3. What is the value of 8C3? That would be 8 factorial divided by 8 minus 3 factorial into 3 factorial. That would be 8 factorial divided by 5 factorial into 3 factorial. How much would that be? That would be 8 into 7 into 6 into 5 factorial divided by 5 factorial into 3 into 2 into 1. We can cancel out 5 factorial and 5 factorial. 3 into 2 and 6, we can cancel them also. So you are left with 8 into 7 and 8 into 7, that will give you 56. So how many triangles can we form using 8 points? That would be 56 triangles. So the number of quadrilaterals that can be formed using 8 points as any 4 of them as vertices would be 70. The number of triangles that we can form using any 3 of the 8 points would be 56. The answer would be the difference between the two, right? So 70 minus 56, that will give you 14. So the number of quadrilaterals that you can form using 8 points is 14 more than the number of triangles that you can form using the same number of points. So the answer would be 14. Okay, this was recently asked in a state PSC examination. Now I think you got a very good idea of combination and how to solve the problems on combination using the formula. Let's go to your homework question now. This is your homework question. It was asked in the year 2023 in CSE paper. ABCD is a square. 1 point on each of AB and CD and 2 distinct points on each of BC and DA are chosen. How many distinct triangles can be drawn using any 3 points as vertices out of these 6 points? Okay. What is the question telling us? The question says that ABCD is a square. ABCD is a square and 1 point on AB and 1 point on CD are chosen, and then 2 points on BC and 2 points on DA are chosen. Using these 6 points, how many triangles can you form? Using the same concept that we used for solving the previous problems, using the same formula, you can solve this one. Do solve it and leave your answers in the comment section. We will answer this question in the next classes video. Okay. Now it's time to answer the homework question of the previous class. Previous class, I mean episode 41. This was the question asked in episode 41. What was the question? It was a question on permutation. If 2 boys and 2 girls are to be arranged in a row so that the girls are not next to each other, how many possible arrangements are there? Okay. Now they are talking about arranging 4 people. 2 of them happen to be boys and 2 of them they happen to be girls. In how many ways can they arrange these 2 boys and 2 girls such that the girls are never together? and we had discussed one particular method to solve these type of questions. How? First, let's find out in how many can 4 of them be arranged in a row without any condition. So these are the 4 places in which they can be made to stand or sit. In the first place, how many options do we have? Out of the 4 people, we can make anyone occupy the first position. So we have 4 options. In the second position, we have, since we would have placed already one person in the first position, for example, if the names of the boys and girls are A, B, C and D, if A takes the first position, only B, C and D, only 3 people can take the second position. So we have only 3 options for the second position, and then we have only 2 options for the third position by the same logic, and ultimately we would have only 1 option for the last position. So irrespective of the condition, without considering the condition given, in how many ways can 4 people be stand or sit in a row? That would be 4 into 3 into 2 into 1, that would be 24 ways. Okay. Then we shall imagine that 2 girls, they are always together. This 24, it gives you the number of ways in which the 4 people can be arranged in a row without any condition. Now let's imagine another condition. Imagine a condition where the 2 girls are always together. How do we solve that? We will imagine the 2 girls as one block. So we will consider only 3 positions, because girls being one block, we will consider them to occupy one position. So in the first position, we will have 3 options. It can be either of the 2 boys, boy 1 or boy 2, or the block of girls. So you have 3 options for the first position. For the second place, you have 2 options, and for the last position, you have only 1 option. So you can arrange them in 6 ways, such that the girls are always together. However, the girls can be interchanged among themselves, right? Girl 1, girl 2, girl 2, girl 1. In all the 6 ways in which you can arrange them, there will be another way. For example, in the 6 positions that we can think here, girl 1, girl 2, let's say girl 1 always stands next to girl 2, stands left to the girl 2. Then there will be always another possibility where girl 1 will be standing to the right of girl 1. So there is an internal permutation, internal arrangement possible. So in how many ways can 2 girls in how many different ways can 2 girls stand? That would be 2, right? Either she will be on the left or the other one will be on the left. So you will get 12 actually. If you do not understand this concept, just watch episode 41 again, and there I have explained the same concept in detail. Then come back to this question, you will understand it better. So in 24 ways, 4 people can be made to stand in a row. In 12 ways, 2 of them they can be made to stand there, such that 2 of them they are always together. So when they ask you in how many ways can they be made to arranged in a row, such that those 2 are never together, we will just subtract 24 by 12, because we are excluding this condition, right? The condition in which they are always together. So there are 24 ways in which they can stand in any manner, and there are 12 ways in which they can stand. There are 12 ways in which they can stand such that the girls are always together. So to find the condition where the girls are never together, we will just do 24 minus 12, and that will give you 12 again. So what will your answer be? Our answer will be option C, 12. Also, I had not given you the answer for episode 5. So I will cover here itself that one. It was a question on reading comprehension or passages. Let's read the passage and let's answer this question. To encourage research is one of the functions of a university. Contemporary universities have encouraged research not only in those cases where research is necessary, but on all sorts of entirely unprofitable subjects as well. Scientific research is probably never completely valueless. However silly and insignificant it may seem, however mechanical and unintelligent the labors of the researchers, there is always a chance that result may be of value to the investigator of talent who can use the facts collected for him by uninspired but industrious researchers as the basis of some fruitful generalization. But where research is not original but consists in the mere rearrangement of existing materials, where its object is not scientific but literary or historical, then there is a risk of the whole business becoming merely futile. Okay, let's read the question and the assumptions now. The author's assumption about scientific research is that it is never very valuable, it is sometimes very valuable, it is never without some value, it is always very valuable. Just go through the sentence that I underlined. Scientific research is probably never completely valueless. Never completely valueless. Now come back to option 1, option A. It is never very valuable. No, they are telling us that it is never valueless, not valuable, not never valuable. It is sometimes very valuable. No, it is never without some value. Yes, it is always very valuable. No. Look at option C. It is never without some value. It is never completely valueless. They are almost synonymous. The never completely valueless and never without some value, they are almost synonymous, and that will be your answer, option C. Okay. I hope that you liked today's video. If you liked it, do watch us regularly. We upload one episode every alternating day. Also, do share the YouTube link to this video to your friends through WhatsApp groups and Telegram groups. All the best, and most of all, a very happy studying.